Welcome to 48th lecture in the course of Industrial Engineering and Operations Research. We are discussing very important topic of Industrial Engineering and Operations Research, that is project management, and in that I am discussing critical path method, and I have already told you that how to obtain critical path and how to ascertain critical activities. Now today I am going to tell that what do you mean by float of an activity. Float means basically leeway. In the critical path there is no float, that means each activity has to be done precisely at that time and you cannot relax. So float means after computing earliest and latest times for all activities, the slack time for each activity has to be evaluated. That is slack also, that is float also. Slack time is the length of the time an activity can be delayed without delaying the entire project. Okay. So in that there are two terms, one is the free float or free slack, and there is a total float also. So floats or slacks are the slack times available within the allotted span of the non-critical activity. That means float will be present only in non-critical activity. That is why it is non-critical. That means you can take some freedom, but not that much. Okay. The two most common floats are the total float and the free float. Okay. So this one, so how do we find out slack or float? Slack is equal to latest start time minus earliest start time. So that means latest start minus earliest start. Okay. So we are doing that latest start. Latest it should start by on 10th day, but earliest it can start 7th day. So that means you have something like 3 days float is there. That means similarly you can also say that LF minus EF, latest finish minus earliest finish is also. Both the things are basically same, because latest finish is latest start plus duration, activity duration, minus earliest finish means ES minus duration, because that duration minus both duration I can put in bracket. This is then it becomes, so duration cuts, you get LS minus ES. So ES is earliest start of an activity, LS is latest start of an activity, EF is equal to earliest finish of an activity, and LF is equal to latest finish of an activity. This is important. Okay. So slack time, the activities with zero slack are called critical activities. I have already told that what will be characteristic of that. Of course that latest finish will be latest start plus duration, this will be there, otherwise this is the thing. That means if you want to follow activity on this one style, okay, so here if it is in critical path, then 3 conditions are to be met. Okay, that means values at these two rectangular, that means earliest start of this, earliest occurrence of this event, and this event have to be this event. Okay, this is, suppose this is this and this is this. Okay, so suppose this is x, this is x, and here this is y, this is y, and y minus x should be duration d. So anyway, so the activity with zero slack are called critical activities and said to be on the critical path. The critical path is a continuous path through the project network that starts at the first activity in the project and terminates at the last activity in the project. Always it will be like that, and it includes only critical activities, that is activities with no slack time. So this can be another definition of critical path, that it is a path in which all the activities have zero slack time. Okay. So computations, critical path computation, how do we do? Computations are done for finding total duration needed to complete the project, categorization of the activities as critical and non-critical, and activity is said to be critical when there is no leeway in determining its start and finish time. That means something has to start whatever precisely. A non-critical activity shows some scheduling slack. Okay. Now example, calculate the slack time for the activities as per the information provided. I am showing the symbol. I have told that in each node this is activity is indicated by this letter, then in the bottom this is the duration of the activity, and then earliest start time, earliest finish time, latest start, latest finish. So, this entire data is given, and we have also showed that how it can be done. Now, you can, and these I have given the chart also, that whose diagram is this, activities and their predecessors and durations are shown. So, suppose we have this type of situation. For each activity you can put that activity A, activity time, earliest start, earliest finish, latest start, latest finish, post data. Then slack is LS minus ES, latest start minus ES, or LF minus EF, both things are same. So, this is 0, and therefore, since slack is 0, therefore, it is on critical path, you say yes. Activity B, we can have, this is 2 0, earliest start is 2, this is latest start is 7. So, here slack is 7, LS minus ES. So, it is not in a critical path. Okay. So, we say that no. Okay. And then here activity C, it is slack is 0, it is on the critical path. Activity D is 6, this is no. Activity E is yes, it is in the critical path, like that. So, the LS, EF, LS, LF and slack time of all activities are shown in table. Activity B has slack time of 7 weeks, its LS is 7, its LS is 7, activity B, and earliest start is 0. That means, latest it can start on the 7th day, earliest it should start on the 0th day, that means immediately. So, its latest finish is 9, because activity duration was 2 and earliest finish is 2. It implies that activity B can be delayed up to 7 weeks, if we are talking in terms of the week. Otherwise, whatever unit you are following, day, week, year, month. Okay. So, here activity B can be delayed up to 7 weeks, while the project B is still completed in 19 weeks. Okay. Means, provided you want to finish it in 19 weeks, then you can still delay activity B up to 7 weeks. Okay. That is the significance of the float or slack time. Okay. So, you can delay like this. Other activities A, C, E, G, H have no slack time. Okay. So, they are, see, they are not having any slack time, slack is 0. In such cases, delay of any activity will delay the entire project. Then you cannot finish in 19 weeks, you will have to take more time. So, example, show the critical path of the project, find the project completion. So, this is given like that, and you say that if this type of thing is given, you can show the critical path, you can mark that, and project completion time is 19, you can conditions is. So, we say that project completion time is 19 weeks and critical path is shown by blue line, that is you start, then go to activity A, and then you go to activity C, then you have to go to activity E, this is G, H. So, you see this is a continuous path, and what is that continuous? On this continuous path, each activity is critical. How do we know that activity G is critical? Because here if you see that this all is matching 17, 17, 11, 11, 11, 11, 7, 7, and of course 7 minus 6 is 11, that will be there, 7, 7, 3, 3 matching. That means earliest start and latest start is same, and similarly here also 3, 3 matching. Of course, 3 minus 3 is 0. So, that means earliest finish is equal to earliest start plus duration, and here of course that this is 0, this is not an activity, but that just I am marking. Whereas in the other path you see that here it is 7, this is 10. So, that means latest finish is 17, but earliest finish is 10. So, that means there is a gap. Here also this is 7 and 14. So, therefore, similarly here also in activity D also it is not a critical, because 11 and there in the top there is a 5. that means latest it should finish on 11th day, earliest it can finish on the 5th day. This is 3, this is 9, so this is also, this is 2 and this is 9. So this is how that we can see this one. So critical path follows the activities with zero slack. Okay. So activities with zero slack has to be paid attention. So therefore you make the path, this path start A, C, E, G, H is the longest in the network. Activities B, D, E, F are not a part of critical path as they have slack of 7, 6 and 7. So here there is slack of 7, you see 10 minus 7, and there is slack of 6, that is float of 6 you can say, and this is 9 minus 2, that means 7. Okay. So these are this one. So table shows the calculation of slack of each activity. Slack means float. So you can say slack is equal to LF minus EF, and this is LS minus ES. We can say slack, or we can say float, FLOAT, float. So you have gone up to this and you have seen that. Now total slack time means what? Delaying activity B causes both activities B and D to lose their slack. This type of slack is referred to as total slack. When two or more non-critical activities successively appear in a path, they share the total slack. So total slack is basically this much, but there is something called free slack, free float. Suppose we give example, it is planned to launch an electric car in the market. Total 7 activities are needed as per the information provided. Find out the total and free float of the activities. Okay. So what happens that if we make the diagram start and this is equal to this one, and then we say that these activities have been given, market survey is first, then after that A. So you do that A, after that you make the B, but B has got before that, then C can be done, C can be done after A. So you make that C here separately, then D can be done after B. So you make D here, and then E can be done before C. So you can make E here, then you can have D and E both should be done before F. So therefore in F two things will join, F and E, and then G can be done before F. So this is the thing, and here you write this thing. You can keep moving in the forward path. This is 0, this is 0 starting, then 0 plus this activity takes duration 4. So 0 plus 4 is equal to 4, then 4 plus 6, 10. This is already finished, that this is 10. This is earliest finish is 10. If it is finishing at 10, so earliest start is 10, 10 plus 8, 18, 18 will come here, but we have to see, we have to pay attention to other path also, because from other side also something coming. So because here two arrows are joining, so that's why you have to pay. So therefore better to make that C first, because in the C only one arrow is coming here. So you see activity A is the only predecessor and it is finishing at 4. So it is starting at 4, and of course that activity duration C is equal to this is equal to C, and this is equal to basically C plus 5. I think there is a misprint. This is 5 and this is actually 5. Okay, this is actually 5. Okay, 5, 5. So that is why that no, this is not 5, this is 3. Okay, because 9 plus 3 is equal to 3. So this is what basically 3 activity duration. Somehow it became 0 here. So this is 5 and this is this one. So you see that here it is finishing at 12 and here it is finishing at 18. So therefore it can start at 18 only. That means maximum of that. And then 18 plus 7 is equal to 25. That means starting and it will end at 29. Okay. So that means total days now 29. Now backward pass, you start from backward way. So this is 29 minus 4 is equal to 25, and 25 minus 7 is equal to 18. And now here you have to see that 7 minus 18. So if you go to that one, 7 minus and this is 18. So this 18 will come here and of course 18 minus 3 is 15, then 15 will be here, 15 minus 5 is 10, and then 10 minus that means 10, this is here 10, and now you have to see 2 arrows are going here na, coming out. So, you have to complete this path first. So, you see that this is 18 and this is 18, and of course, that you know that it is here 18, latest start is 18. So, here you have to put 18, 18 minus 8 is 10, that means earliest that means latest, this is latest finish, this is latest start. So, 18 minus 8 is 10, and this is 10, 10, this is 10, this matches this, 10 minus 6 is equal to 4, and then 4, this is 4. So, you can put here 4, but from here this side you can put basically 10, but you have to take the minimum one. So, therefore, you will put 4 only, minimum latest start of B, comma latest start of C, both the things you have to see, because from activity A, 2 other activities you know that succeed, okay, B and C. That means activity A is immediate predecessor of activity B and C. So, you have to see both the things, okay. We have to minimum, you take the minimum time of latest start of B and latest start of C. So, latest start of B is 4, but latest start of C is 10, but you have to take minimum of that. So, it is 4. So, that is why it is 4, and then 4 minus 4 is 0. That means this is latest finish. We say that latest finish, okay, this is latest finish, it is written also here. So, this is basically latest start, okay. So, latest start is just 4 minus 4 is equal to 0, and this is what, that is the situation. So, now critical path is basically shown like this A, because this is matching A, B and D. B is matching because everything is here same, 10, 10, 4, 4, 18, 18, 10, 10, is it not? That means earliest start, latest start is same, and F, 18, 18, 25, 25. So, A, B, D, F, G, and these are non-critical, okay. So, if I plot them, if I make in a table, then I can write activity, then duration. We can say that earliest start time of activity J, EFI and LSI, LFJ, okay. So, we can actually find out the, for each activity we can find out the float, okay. So, we can have this one, and we can have activities this one. So, earliest start of an activity, latest start, this is current activity, and I have also written succeeding activity by J, okay. So, current activity, suppose activity A is there, and it is critical activity. Some activity is not critical, say suppose C is not critical, here earliest start is 4, this is 9, but the earliest start of activity J is 9, okay. So, that means earliest start of activity is 4, but the other one is basically 9. So, here we have to understand that one thing, important point, total float of activity Ij is basically latest occurrence of event J minus earliest occurrence of event I minus activity duration, okay. That means if you talk in the event terms. So, that means we say latest occurrence of event J minus earliest occurrence of event I minus activity duration. But the free float of activity is basically earliest occurrence of event J minus earliest occurrence of event I, okay, earliest occurrence of event I, we have to say that earliest occurrence of event I, and then we have to say that minus activity duration. So, instead of latest occurrence, you have to see earliest occurrence of event J. If the earliest occurrence and latest occurrence is same time, then no problem. So, that means free, but so therefore, free float is always less than or equal to total float. So, that means this you always remember. So, I am putting some red flagging rule, that means if free float is equal to total float, then activity can be scheduled anywhere within the span. So, it can be scheduled anywhere within the span, that means earliest occurrence of event I and comma latest occurrence of event j. If free float is less than total float, then the start of the activity can be delayed by no more than the free float relative to its earliest start time without causing schedule conflict. So, that means although you have got freedom, but if you delay that thing, then you know other activity will also be delayed. Any delay larger than free float must be accompanied by the corresponding delay of all the activities immediately succeeding it. Okay. So, that means again I pay your attention that suppose we have said that if you know we have to see the other activity also. Suppose we have to say that say activity C is there, and in activity C it can start at earliest start is 4, and naturally that here actually free float. Okay. So, you see total float here is basically 6. Why 6 total float? Because earliest this I start in 4 and latest start is 10. So, that means that event. So, 10 minus 6 is equal to 10 minus 6 is 10 minus 4, 10 minus 4 is equal to 6. So, that means total float is obviously 6, because latest this activity should be started at 10th day and earliest it can be 4. So, just pay attention to these two things 6. But then why I am telling that there is no free float? Because yes, earliest start of event j is basically 9 and earliest finish is 9. Okay. So, that means earliest it can finish only by 9th day. So, therefore, this is the thing. So, suppose earliest finish is coming 9, although there was some freedom I would have done that, but it is this one. So, therefore, free float will be done ESJ means event j, ESJ minus EFI. Okay. That means this is the earliest start of event j minus earliest finish time of event I. Earliest finish can be 9. Okay. Earliest it can finish by 9 only, and earliest start can be 9. So, 9 minus 9 is 0. So, therefore, here the free float is basically 0. On the other hand, if you pay attention to activity E, so activity E's earliest start is 9, and what is the latest earliest start is 9. So, if we want to say latest finish time is basically latest finish LF of this one event I. That means event latest finish of event I is actually 18. So, this is actually this one. So, this will be 18 9 minus no latest start of event I. Okay. Latest start of event I is actually this one. Okay. So, you say that 15 minus 9 is equal to 6. Okay. That much you have got. Okay. So, this is this one, but if you see that free one in this case ESJ, that means this is actually starting time is 18. Okay. And EFI is actually earliest finish time is 12. So, 18 minus this one is 6. Okay. So, that means it is both are matching. Okay. So, that means latest finish time and this is this one. So, therefore, here we have already said that about this one that yes, yeah, I have already showed that total float of activity Ij is equal to latest occurrence of event j minus earliest occurrence of event I minus activity duration and free float of activity I in J is equal to earliest occurrence of event J minus earliest occurrence of event I minus activity duration, and free float is always less than or equal to total float. Okay. So, this much for today, है ना. Thank you very much. We will continue the discussion later on.